In this section, I'm going to tell you the relationship between functions and velocity and acceleration. As we have learned derivatives, we can apply the derivatives inside this function and find what is the relationship between them. So, if you want to take the first derivative of a position function, we would see that we got another function that is related to the velocity function. So, we know that first derivative of a position function will be equal to a velocity function. And it's the same for the velocity function. If we get the second derivative of the position function or the first derivative of the velocity function, we would get an acceleration function. Now, for understanding this thing better, I give you an example. So, the example says an object dropped from the second highest rung of a Sears catalog. The position function for the object is pt equal to negative 16t squared plus v naught t plus h naught. In this case, v naught is the initial velocity, which is 0 in this case. And h naught is the initial height, which is 1,542 meters. So right now, if we want to write the main function, and using this function and this information, we have to apply those two values inside this function and write the final function. So we would write p of t equal to negative 16 t squared plus v naught of t, because v naught is 0, so we will have nothing here because it's going to be 0. And h naught, which is 1,542 meters. This is going to be our main position function. Afterward, as I told you, if we get the first derivative of this function, we would have the velocity function. So right now we're going to do this. We will write the v of t, which is going to be velocity function, equal to the derivative of this part going to be 2 multiplied the negative 16, which is going to be negative 32, multiplied by t, and the power going to be decreased by 1 unit and give us 1, which we don't write, plus 1,542, which doesn't have any variable. Therefore, if you get the derivative of this one, the derivative is going to be 0. So our velocity function is going to be negative 32 multiplied by t. If you get the other derivative, I mean the second derivative for the position function, we would have 0. So therefore, we would see that we don't have any acceleration function for this example. Now we have the velocity function, and the question part B asked us to calculate the average velocity between t of 2 and t of 3. So it's so simple. We just apply those two values inside this. T of 2, negative 30, negative 64, and t of 3, is negative 96. So we would have that t, the velocity at t equal to 2 is negative 64, and at t equal to 3 is negative 96. So we're calculating the average velocity. We would write the function that negative 96, negative 64 over the difference in time, which is 1. Therefore, we would have negative 96, negative, we're going to be positive 64, and it would give us a 32 over 1. Therefore, our average velocity equal to 32. Which we know that velocity is the unit for velocity is meter over in this case. Now I have changed the example function, the function that is given in the example, to 16t to the power of 3 v naught t squared plus h naught t. I did that because I want to find a way to calculate, to make an acceleration for this question. So also, I changed this value and I put it equal to 1 because I don't want to omit the this part, v naught t2 squared. So I'm gonna do the same thing with this function. I'm gonna first get the first derivative from the position function at the first level, then I'm gonna get the second derivative, and therefore we're gonna have the acceleration function. So we do the same thing. We will start with p of t equal to negative 16 multiplied by 3 will gonna give us 48, negative 48 t squared plus v0 is 1, so it's multiplied by 2 in the derivative and give us 2t, and h0t, which is gonna give us the same number. This one is the velocity function right now, because it's both derivative, we got derivative and we put these values inside. Now I'm gonna get the derivative again from this function. So I write the a of t, which is acceleration function, is equal to negative 48 multiplied by 2, which is gonna give us negative 96t plus 2, and this one gonna be 0. So as we can see, as I change the example, we right now have the acceleration function. If we reach to this level, the question might ask us, like, find the average acceleration between t equal to 2 or 3. This type of this question are exactly the same, but we just must know that the derivative of the position function give us the velocity, the derivative of velocity give us the acceleration function.